Hello everyone, thanks for joining us once again. Today we are looking at circle geometry, grade 11 circle geometry. So there's all those important theorems. There are many of them that you learn. There's also some important axioms that you are expected to apply. All of this incredibly important for grade 12 because, as I've been saying through this whole session, in grade 12 we need to remember our circle geometry. We will be asked questions on this type of thing. All right, let's have a look at question 3. So what I always like to do is I like to write down immediately when they give me information, I like to write it down onto the diagram, right? AOC is the diameter of the circle. So AOC is the diameter with center O. So that tells me that AO, OB, OC, and OD are all equal. Why? Because those are radii. Okay. If I were to join A to E, this angle AEC would be 90 degrees. We may not need this, but it's always a good idea to have this information on hand, just in case. So therefore, and the reason for that would be angle in semicircle. They tell us that F is the midpoint of chord EC. So that's important because this now implies we can use the converse of the line from center theorem, because we know that OF is the line from the center. It's bisecting chord EC. So that means that OF must be perpendicular to EC. And that's just the converse of line from center theorem, right? Because EF is equal to FC and OF is the line from center, angle F must be 90 degrees. So therefore OF must be perpendicular to EC. All right, and then they say that angle BOC is equal to angle COD. That's marked with the same markings on your diagram. Those are not X's because we can see our little X there as angle ABO. Those are just showing you that angle BOC is equal to COD. Okay, good. So we've got an idea of what's going on the diagram. I see because there are radii, this little angle A here, which is angle BAO, that's also going to be X, because OA, as we've already mentioned, is equal to OB. And there we go. There's the diagram here. Let's find angle A. So this is the one that we want here. We've already done it. Angle A is equal to angle B is equal to X. And the reason for that, AO is equal to OB radii. So, or you can say AO equals OB radii, and we know that angles opposite equal sides. All right. Then we needed to find angle COD, which is the one at the center. It's more than one way to do this, guys. The one way that you might see is the exterior angle of triangle. So BOC, this one, is going to be equal to 2x, because it's the exterior angle of triangle BAO, and therefore angle COD will also be 2x because it's equal to angle BOC. They told you this. Another way some of you might see this is if I join chord BC, then I get the angle at the center is 2 times the angle at the circumference. However, whichever method you use, you should get that angle BOC, so angle COD is equal to angle BOC. We know that angle BOC, in fact, let me go to the next page. Angle BOC is equal to 2x. There's more than one way we could do it. I'm going to say angle at center theorem. So therefore, the one that we want, which is angle COD, is also going to be equal to 2x. All right, so we've got this angle is 2x. They ask us to work out angle D. So angle D being the one on the circumference here. Okay, so this is where it's very important to remember that bit of information that we read right in the beginning, where it said that FC was equal to EF. That's important because it's the converse that we can use of the line from center theorem, and that gives us an angle in triangle EFD. So this is what I'm saying here, and let's clear the screen so you can see this a little bit better on your diagram. Angle OFE is equal to 90 degrees y converse of line from center theorem, right? So therefore, and I'm not writing it all down, I am speaking it, so please make notes of it as you go. So therefore, angle EFD is equal to 90 degrees, all right? And we know that the one we are looking for is this one here. Okay, and we know, what else do we know? We need to work out we know that this angle, let's see how we're going to join this. This angle here, if I join C to D, we see that CD takes me to the circumference, center first and then to the circumference. Okay, so I'm saying circumference but showing center. There we go. So CD takes you to the center first and then to the circumference. So therefore, angle at center, and this one's a tricky one to see because of the way the diagram's positioned. Angle at center is twice the angle at circumference, but we know that angle COD we've just proved is 2x. So therefore, angle CED will also be a half of angle COD because angle at center is twice angle at circumference. So therefore, angle E is going to be equal to x, and the reason for there is angle at center theorem. So if angle E is equal to x, and we know that angle EFD is 90 degrees, then I can find angle D by using angles in a triangle. So angle D is going to be equal to 180 degrees minus 90 minus x. 180 degrees minus 90 is going to give me 90 degrees minus x. So angle D here is 90 degrees minus x. Okay, and what I'd like you to do, because remember there's more than one way to get an answer in geometry, see if there's another way that you could get to angle D. It may be slightly longer, maybe it's shorter, but I think it's going to be longer than what we've just done here. But go ahead and see if there's another way that you can show what the value of angle D is. All right, and that's a little bit of homework for you to have a look at. Right, let's look at the next question. This is question 4. Let's see how far we can get with question 4. So here we are told that P, Q, R, and S are points on the circle with center M. You can see that M is not at the point of intersection of PR and QS. Please don't make the mistake of thinking that PM and MR are radii. That will be a very bad mistake because what it then implies is that all your reasoning from there onwards is going to go wayward. It's going to be havoc. Okay, so M is not centered at the point of intersection of those lines PR and QS. Please note that. PS and QR are extended to meet at T, and do not assume that that means that ST is a tangent. Clearly it's not a tangent because you can see it's touching the circle at more than one point. But please do not make any assumptions about these lines because in geometry it's all logic, and sometimes those assumptions we make which are wrong really affect us when we do questions like these, because obviously it was the wrong thing to say in the beginning, and then every single part of the question you do after that is impacted by that wrong statement that you made. So don't assume things that aren't told or that cannot be shown by use of a theorem. All right, so there's no real theorems that we see as yet. We do see that PQRS is a cyclic quad because all 4 points are on the circumference. And then they tell you that PQ is equal to PR, so that means angle Q must be equal to angle R because angles opposite equal sides. Angle PQR is 70 degrees. Okay, so now we've got information. If that angle is 70 degrees, that means that angle PRQ is 70 degrees because those are angles opposite equal sides. It's an isosceles triangle, PQR. We also know that angle S is the exterior angle of the cyclic quad PQRS, so therefore the exterior angle is going to be equal to the interior opposite, so therefore angle S is also going to be 70 degrees. Because PQRS is a cyclic quad, we can see that angle S, this little s here, is also going to be 70 degrees because of angles in the same segment with angle R. Okay, let's have a look at the question, because we've done all of this working. We have a good understanding of what the diagram says. They say state 3 more angles equal to x, 60 degrees. And guys, we've already done it. Because PQ, and I'm going to do it on the diagram, I'm not going to write it out, but you can follow what I'm saying. PQ is equal to PR, and since they told us that angle PQR is 70, that means that angle PRQ is 70 degrees, and that's because of angles opposite equal sides. Angle PSQ is also 70 degrees because of angles in the same segment, and angle RST is 70 degrees because it is the exterior angle of cyclic quad PSQR. All right, there we go. 3 angles that are equal to 70. They move on to say that angle QPS, so this whole thing here, angle QPS is equal to 80 degrees. And they want us to find the value of SRT. SRT, well, that's simple enough because the exterior angle is equal to the interior opposite, so therefore SRT is going to be equal to 80 degrees. Calculate STR. STR is an angle within triangle SRT, so therefore it's simply going to be 180 minus 70 plus 80. So 180 minus 150, so that means this angle here is going to be 30 degrees. And then angle PQS, which is this little one here. All right, so how do we get to that angle PQS? We've got angle QPS is 80, we've got that angle PSQ is 70. We're simply going to use angles in the triangle, and we'll get that angle PQS is 30 degrees. Guys, I want to leave it there. I want you to try and now put this all together in a proof where you can get marks in an exam type situation. I've gone through the proofs in quite a lot of detail with you. All you need to do is just write it all out. Until next time, cheers.